So now we're going to look at a specific kind of a reaction. Everything is similar in terms of you're going to look at the mole ratio and you can convert from one thing to another. What's different is how the reaction itself is put together and also the information that will be given you at the beginning of the problem. So this long tube thing, this is called a burette, that long tube thing. And then down here, you have something that's different in the flask. So what happens is you can turn this knob here and it lets it slowly drip in. And as it lands in the flask, a little bit of a reaction will happen in the flask. So these are typical acid-base kind of reactions. And everything with moles, it all applies that we were just talking about. So what's different besides the look of it is that instead of starting with a mass or a mole, so the other examples, it was a gram, mass, or it was a mole. So instead of that, what you have is that you will start with a volume and a concentration. And it's not just any concentration. You're going to be given molarity. So this is kind of a shout out to what you've already seen. So if you had 1 liter of something and you knew that the molarity was 6 molarity, remember you rewrite molarity as moles in a liter. So it would be like saying 6.0 moles in 1 liter. And then that leads you to moles right there. And of course the answer would be 6 in that case. So like last time we started with moles or with mass and got to moles. This time we're going to start with 2 numbers, which really quickly we can get to moles, and then everything will seem the same. And a typical titration right here, there's just some quick information. It uses a burette, that's that long tube, and incremental additions, that's just dripping it in. And usually what you know everything about is this top part. Like you have lots of information about what's in the top part. And then like the stuff in the flask is like an unknown, like you don't know what it is. And there is one key word in this, and it's equivalence point. And it's when the 2 reactants, when their mole amounts that are in the flask, like match. So first you start off with everything being just that blue series of moles. But then as you drip it in, you're getting more and more of like this aqua color going in. And then ultimately, you're going to have an exact amount of moles of the blue stuff having react with an exact amount of the aqua colored stuff. And when that happens, it's called the equivalence point because they're equal. All right, so let's go ahead and look at what we need to know here. So as a reminder, this is a way to shortcut some of these problems. Before, when we said 500 milliliters, and you need to get into liters, we would say, well, in 1 milliliter, there's 1 times 10 to the minus third liters. And we would say, okay, so that's 0.500 liters. So now what is suggested is if you can do this math in your head, you're going to save yourself writing in a step. So remember that the 500 milliliters is the same thing as saying 500 liters. 100 is the same thing as saying 100 liters. On the 50, make sure you have a 0 there, and then liters. And then finally on the 10, you got to just have that little 0 there. So that's how you convert any of the milliliters. You just move that decimal to the left 3 times if you're going from milliliters to liters, which is most of the time what you're going to do. You'll be given information in milliliters and you're going to get into liters. So in point of titration, that just means after the reaction. We have HCl. So here's our HCl, and it's reacting with NaOH. I know there's numbers in it, but I'm just like, here's the equation. And then notice that we're making NaCl, and that's because this is positive and this is positive. And then the chlorine is negative and the OH is negative. They've just swapped. And remember, this is kind of like saying HOH. All right, so what information do we have initially? Well, initially we know that we have, and again, I'm putting this in as a liter, so it's this number, 0.050 liters. And then we also have this number here. I'm going to put that one in as a liter, 0.3523 liters. I know that feels like a lot, but I'm just saying it's easier in the long run to just go ahead and convert it in your head and write it down like that. And then it wants to know molarity of HCl. Well, for molarity, I need moles. And I don't have them. I have the liters part, but I don't have the moles part. So I'm going to just put a question mark. I don't know my moles. But this one I do know my moles. It's that 0.250 moles of the NaOH. So this question is not actually asking about any of those. It could. And it could, you could calculate the theoretical yield of this, or most of the time you don't care about the theoretical yield of water, but you could do it. So we're just going to take, this number is it's the solo unit, just a liter, and it's not paired up with anyone. These two are obviously paired up. This one isn't. So we're going to take this and save it for the end. It's going to go, so we are looking for molarity. That's moles over liters. And so at the end, when we know the moles, which we don't know it right now, we're going to take that liter amount and it's going to be going on the bottom. Because remember, this was for the HCl, and that's what we're finding this information about. So I kind of already have that set up. So I'm not going to need to use that number in the factor label, but I do need to do this one. And remember, write moles as moles per liter. So 0.03523 liters times, and I'm going to label it NaOH. I'm not thinking, I'm writing down liters of NaOH, and then I'm looking up and saying, do I have anything to work with? Well, this is the only thing I've got to work with, that molarity. So I'm going to go into moles of NaOH. Now, it wants to know the molarity of the HCl, so I'm not to the HCl yet. I'm just still stuck on the NaOH. But remember, once you get to moles on bottom, you can jump over to moles on top. And then this is an equation that's balanced. You'll notice there's a 1 and a 1 in front. They're understood ones, 1 to 1. And then this is 0.250 moles in 1 liter. You can see how our units cancel out, and our units cancel out, and those units cancel out. And so it's just that 0.03523 times 0.250. And that makes me have 0.0088075, and that's moles of HCl. And if you remember, right a second ago, I know my liters amount. I just need my moles on top, my 0.0088075. So I've already got that number in my calculator. I'm just going to go write divided by 0.05. So that gives me my answer, which is 0.176. Let me double check. Our sig figs are 3. Let's see, my molarity has 3. So not that 0, but this 0, and this 0.